The first way of displaying this data, we could talk about frequency tables. So a variety of ways to look at this. There is one way that's called a frequency table, or sometimes it's called a tally table. Kind of depends on just the level of questioning. A frequency table. And I'm going to put here tally in parentheses because I'm going to use tallies. And a frequency table, a real, true frequency table that measures the frequency, right, is kind of vague, right? Everybody's frequency tables could look a little bit different. And again, that's one of those things we talked about with the statistics unit. Everybody's could look a little bit different. There are incorrect answers. But there are multiple avenues of having a correct answer. So a frequency table just measures the values that are found inside of something. Now, the key to having a frequency table is that the ranges must be even. So, like, I make frequency tables when I'm looking at grades on a test, right? If I give a test to a class, I make a frequency table, and my ranges are 10%. So, like, students that got A's, students that got B's, students got, right? Like, I do it by 10%. I do students in the 90s, students in the 80s, students in the 70s. Because that kind of just helps me figure out what is going on. It helps me analyze the data a little bit. You can choose to increase or decrease. Meaning you can start, when I do my frequency tables for a test, I start with the 90s, right? And then underneath that I do the 80s, and then underneath that I do the 70s, and underneath, right? So my range goes by tens, but I start at the high end and go to the low end.
So you decrease.
I decrease. You can choose to start at 0 and increase, or you don't have to start at 0. You could start at 30 and increase, right? So if I look at this data, let's increase just because we can. And I'm going to do 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69. Anything in the 70s?
No.
Okay, so I can stop there.
I don't think they're all even.
Even as in the same amount of change.
Oh.
So they each increase 9. They include 10 values.
I thought it had to be an even number.
Right, no, not an even number. They increase 10 values. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. That's 10 values fit in this range.
Cool.
And then we're going to record my data. So here we go. The number 30, I'm going to put a tally here. 42, tally here. 43, or no, that's 31. 54, 29, 34, 50, 44, 33, 28, 56, 29. Oh, 32. What do I get to do with the fifth tally?
You gotta put a line.
Cross.
Cross it.
I only have 3 tallies, so
26, 31, 64, 35, 48. There's my frequency table. Literally, it shows the frequency that something occurs. Have you seen those before?
yeah.
Very basic way of showing your data. Another really basic way of showing data is a dot plot.
Dot plot.
Now, the dot plot is made up of dots. You can choose to use X's if you want. You can choose to use stars if you want.
Missile.
A dot plot is where you put one dot for each data value or data piece, not value, on a number line. A dot plot is where you put one dot for each data piece on a number line. The biggest issue with dot plots are those of you out there that are heavy-handed. Your dots or your X's or whatever you want them to be need to be uniform in size, which sometimes can be a little bit difficult. Dots need to be the same size. Again, it's not like get out your laser.
What's that? It's
Like a tiny beam of
But
light.
like if you make like for one, you gotta commit to that for everything. So let's do a dot plot here.
It's not a dot plot if it's not
Gonna draw a number line. And I'll start at 20, 30, 40, 50, 60, 70. And there's 5. One, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oh my gosh, it's gorgeous.
So many little ticks.
So many. Don't worry, in your homework it gave you a number line already drawn.
Thank you. 'Cause I can't.
I didn't want you to,
I can't draw straight.
do too much.
Not that he can't do that many takes, just I can't draw.
All right, so then my data, the number 30. Put a little dot.
Oh, we're like up. And,
The next one is 42, so I put a little dot. See how they're pretty even in size and they're even in height? 31. 54. 29. I'm going to stop saying the numbers out loud. I believe in you, Landon. What happens when I have the same number, but there's already a dot there?
You put it above.
You put it above, it's stacked. So my stacked ones need to be pretty close to the same height, right? Oh my gosh. We did it.
Yay.
So again, this shows frequency. This is a little bit, I mean, the frequency table shows us that most of the data is in the 30s, right? A dot plot shows us a little bit more because the data is actually the individual data, right? So this one shows me that it's kind of clustered in the high 20s, mid 30s, right? So this is a little more descriptive. And then a combination of both of them is called, which is, I make a lot of these for my own data analysis, is a stem and leaf. And a stem and leaf is organized by place value. Stem and leaf is organized by place value. So, you need to have a key for stem and leaf also. All right. Place. So, if I look, my numbers are mostly in the tens, right? So, I'm going to organize it by 20s, 30s, 40s, 50s, and 60s. So this number means 20, the 2 in 20. And then I'm going to put the 1s over here. So these are my 10s places, and I'm going to organize my 1s over here. So if I look, what's my lowest value? 26. So that means 26. Comma. What comes after 26? Is there a 27 data point?
8.
28. So I'm going to put in 8 because that means 28. There's not a 24.
There's 2 29.
There's two 29s, so I'm going to put 9, comma 9. Because there are 4, right up here, 4 values between 20 and 29. 26, 28, 29, and 29. Then I'm going to go into my 30s. There's a 30 value, so I'm going to put a 0. A 31 and a 31. 1, comma 1. See how I'm lining up vertically also? I'm going to run out of space, so I need to move this down. 31, 31. There's a 2, a 3, a 4, and a 5. Yes?
Yep.
Then I go to my 40s, and if I look at my frequency table, there were 7 values. 1, 2, 3, 4, 5, 6, 7. My 40s are 42, 44,
48.
and 48. My 50s are 50, 54, and 56. And my 60 is 64. Now, the cool thing about a stem and leaf, I have to make a key also.
Key.
2 line 6 makes 26. Because maybe they're decimals. Maybe it was 2.6. I don't know. A stem and leaf plot is really cool in the fact that you can make it back to back. Meaning I could put one data set here, and I could put another data set
Right there.
going the opposite way, and I could compare them. So stem and leaf can go back to back. You can put one piece of data going to the right and one piece of data going to the left. What do you notice about my values as they go to the right? They increase, right? I'm putting them in order also.